Alright, let's look at homework 2.8, problem number 1. Alright, so radius of the sphere is increasing at the rate of 3 millimeters per second. How fast is the volume increasing when the diameter is 80 millimeters? Alright, so let's do that. Alright, so we have a sphere, so it's going to look kind of like this. Alright, then the radius is, let's use r for the radius. So I guess we cannot see this side. So the radius is going to be r. Right? So let's say the volume formula for the sphere would be volume V is equal to 4/3 pi r cubed. Right? And what's given is, let's see, so radius of sphere is increasing, so we know that the dr over dt. So rate of change of the radius is 3 millimeters per second, right? And what else? When diameter is 80. So let's see, diameter is 80. So which means that the radius at that point is 40, right? Because half of that would be the radius. Alright, so let's find the rate of change of the volume. Alright, so we just take the derivative with respect to t. So you will get the derivative of v with respect to t. So dv over dt is equal to. Alright, so you have 4/3 pi, just a constant, so I put it there. The derivative of r cubed would be put 3 in front, r, then subtract 1 from the power, so it's squared, and then you have to multiply by dr over dt. Right, so that's the chain rule. Then clean it up a bit. So you see that there's a 3 on the bottom and 3 on top. So what you get is, let's see, 4 pi r squared dr over dt. Alright, then we just plug in what we already know, so it's going to be 4 pi. Alright, r is 40, so it's 40 squared, and dr over dt is 3, so multiply by 3. Alright, so this is going to be equal to, let's see, I'm going to just multiply 3 and 4 pi, so it's a 12 pi times 40 times 40. So 4 times 4 is 16, and you're going to have 2 zeros. Alright, so what's this? Alright, so 1600 times 12. Right, 0, 0, 2 times 6 is 12, and 2 times 1 is 2, so 3. And then you have a 0061, right? So 19200, right? So it's a 19,200 pi, right? So so that's cubic millimeters per second, right? So let's type it in. Alright, so what we found was 19,200 pi. So Greek letter and the pi. Alright, so let's go submit and for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.